Alright guys, so welcome to today's tutorial video. In today's tutorial video, we will take a look at how this Mochi Buzzcut right here was done. Alright, I know that this Buzzcut is not that good, alright? So, especially when you try to compare this to the Grand Prix Online ones, there is a lot of stuff missing, as I've already mentioned in the previous video. But one thing many of you have mentioned is that this one is not boned, alright? And I have to disappoint you. This one, so this Mochi arm, is actually boned. So when I open up the animation editor, you can see that I have animated this thing right here, okay? So I was really about to animate this. The problem was that once I have exported this animation, and once I've tried to load that animation, so this exported one, it refused to load it for whatever reason. And that's the reason why I was not able to animate this. Otherwise, this would have looked far cooler, alright? But you can't have anything in life, so that's just it. Now, so how was this done, alright? So, as you guys know, or at least those of you who are familiar with, you know, the relationship between client and server, and when it comes to the attacks, you guys know that we need a local script, which is responsible to detect the inputs, alright? So this is this one. Now, apart from that, we need a remote event, which is there to communicate between client and server, but also between server and client. So once an input was done on a local script, we fire server to this remote event, and then the server script right here notices that fire server and then reacts to it, alright? And this reaction is that this Mochi Buzzcut, so this attack, is visually done on each player. And this happens by fire clienting this remote event, and fire clienting to everyone. And this fire client to everyone is noticed by this local script, so this Mochi visuals local script, and this one will construct this this attack. Right, so that's just a short description on how this works, and now let's take a deeper look inside. So as you can see, we have this Mochi Buzzcut local script, and we have a variable called UIS, so user input service. What this does is that it detects the user's input. Now, UIS.input began is an event, which happens when an input has to begin, as the name suggests, alright? And the arguments we receive is the input itself, so mouse button, key button, a key, I'm sorry, or any other input. And GPE stands for Getting Processed Event, and this tells us whether this input was done on purpose or not. Alright, so if not GPE, so GPE furthermore stands for whether you have interacted with any in-game elements while doing this input. And if this is not the case, then we want to check if input.keycode, so we are looking out for a key, equals enum keycode Q, so whether the key which has been pressed is Q. And if that is the case, then we refer to this Mochi Buzzcut remote event, which is inside of the replicated storage, and then we fire server this with the argument initiate. Now, as I've told you, this server script right here reacts to this. So up here, we refer to this Mochi Buzzcut once again, but this time we call this on server event. And this happens when you fire server this remote event, and we look out for 1, 2, 3, 4, 5 variables, 5 arguments right here. So the first one is being passed onto automatically, so with each fire server, and that's the player, alright? The second one is called what, and it is, you can consider it as some kind of task, so it tells the server script what to do, because we will fire server this remote event multiple times, so not only from this script, also from this one. Therefore, we really have to differentiate in between all of those different tasks. So we have 2 in total, so initiate and check for attachment, but we will get to this later. And then we have a bunch of other arguments, but we will get to these later as well. So they're not part of this initiate thing right here. So I've told you, if what is initiate, so this guy's task right here, then we refer to this Mochi Buzzcut remote event once again. Then we do a fire all clients, as I've already explained to you. And this time we have another argument called visualize, and then the second argument is the player. So when it comes to this visualization on the client side, you really have to tell every client you're fire clienting to who the performer is, and that is what is happening right here. So this particular second argument is the performer of the attack, so keep that in mind. And the first one is the task, alright? So you guys should know that I'll have to use this argument, this first argument, to tell the script what to do. because as you can see, this one not only has one task, but also another one down here, So attached, therefore we have to differentiate once again. Now, let's get inside of here, all right? So once you fire client to every client, this one is important to consider. So first of all, we have this first argument, this first variable, I'm sorry, called cam, and it refers to the current camera of the workspace, all right? So basically to your camera, so the camera of this client. Now right here, we refer to this Mochi Buzzcut once again, and this time we do on client event, and this, as the name suggests, is an event which happens when you have fire cliented this remote event, which you have referred to earlier. And the arguments we receive is the tasks, so what, the performer, as I've told you, and another argument, but we'll get to this one later because this one is not part of this visualize task right here. Now, if what is visualize, then we do all of this. So let's go through this. Right, so we start off by making our performer unable to move, by first of all setting the walk speed to 0, setting the jump height to 0, and actually anchoring the humanoid root part to prevent it from rotating. I think that was the reason why we've done that. Now down here we have set up a table. As you can see, it contains the left upper arm, the left lower arm, and the left hand as an index right here, and the values are 1. All right, we have set up this table to have some kind of automated check right here. All right, so what happens right here is that we loop through the performer's character, and we check if there is any body part which has these as a name, okay? In order to be able to index them like this, they have to have a value right here, and it doesn't really matter what kind of value you put right here. You could even put 2 or 3 here. It doesn't really matter, all right? The only thing that matters is that there is a value. Now, if it was able to find any of those body parts right here, then they will be set to transparency 1, means invisible. So we obviously make our left arm right invisible. Now right here, we set up a variable called Mochi arm, and then we refer to this Mochi arm inside of the replicated storage, and we clone this one. Yeah, we set the handle transparency to 1. Yeah, we set it to 1, so it is at 0 by default, and then we parent this to our character. So we put it inside of our character, and right here we set up a Weld, and the parent is this handle right here. All right, so you can consider this handle as the main part of this Mochi arm, or literally the Mochi part itself. Now, part 0 of a Weld always is the part you're welding something onto. In this case, we are welding the Mochi arm onto our upper torso. All right, that's the reason why our part 0 is our performer's upper torso, while part 1 is our Mochi arm's main part, aka the handle. And this C1 right here is the C frame we go with. So as you can see, we have to move 15 on the x-axis, minus 0.15 on the y-axis, and then we have to rotate this. All right, so this is just the position of our arm. And right here we set up a tween, and this tween will tween this Mochi arm from transparency 1, as we have up here, to transparency 0. So it will create a transition in between. That's what the tween service does. And you have to put the instance you want to tween right here, then the tween info, aka tween settings, so the time it takes to tween everything, the easing style, the easing direction, and then the property you want to tween, and the goal, the goal value, let's say, so the goal state of property you want to achieve. All right, and then you have to play this tween in order to make it happen. And right here we have a variable called loader, and we refer to our humanoid's animator instance, and then we load an animation. So that function can only be called on animator instances right here. And load animation requires the animation you want to load inside of those brackets, which is script dot player anim1. And we play this loader. And I think that this was the swing animation, so where the Mochi arm is being swung. Yeah. And right here we have set up another variable called swinging. And this one, as the name suggests, is a variable which tells you that you're currently swinging the Mochi arm around. And this one is important because down here we have a bunch of loops which have the swinging as a condition. All right, but we will get to this later. Now right here we have a check, okay? And this check checks whether our local player right here, so the owner of this local script, is the performer itself. Because if that is the case, then we want some camera movement to happen on this performer right here. So we have created the port, and we have welded this port onto our handled core port. So this handle, aka main port, main Mochi arm, contains another port called core port, and this one is welded onto this handle. And this port we are now creating is invisible, is not anchored, is mastless, and can collide as faults. And this welds this port onto our Mochi arm. And we set the camera subject of that of our performer right here to this part. All right, and let me explain you why we do this. So this is of course some camera effect right here, so that the player's cameras focus on the arm itself and picks up how all of these enemies are attached to this Mochi arm after they've been hit. And this is a feature which only happens to the performer. All right, that's the reason why we have this check right here. Now down here we have a variable called swing sound, and there is actually a sound right here called swing. So script.swing clone. So we clone the sound and we put it inside of our Mochi arm, but I do not play it for whatever reason. So swing sound play, come on. Yeah, forgot to make it play, sorry for that. Now right here, coroutine will resume. So what coroutines can do is that they run this code inside without interrupting the rest, without yielding, without pausing the script call however you want to. So you can consider that this code is being run in the background, all right? So without interrupting any further progress of the script. So let's take a look at this code, which has to be run in the background, otherwise it would interrupt the script. So what kind of code is this? So what happens right here is that we loop through the workspace, okay? And by looping through, I mean we use get descendant. So we get literally anything inside of this workspace. And if the thing we're currently at is a model and has a humanoid inside of it, then we can tell that this is a character model, okay? And then we want to create another coroutine and a coroutine. So we're creating this coroutine to interrupt this one, okay? Makes sense, hopefully. And we have to create this because we are using a loop inside of here, all right? So if we would not use this coroutine, then this whole code would pause after finding the first target. So after finding the first character model right here. And what does this, what does this loop do? So while swinging is true, it waits first of all to prevent this whole script from crashing, but apart from that we have a check which first of all checks the distance in between this character model, so the character model humanoid root part's position minus the Mochi arm's position, and if that position, that magnitude, is not greater than 10 or is 10, and there is no instance inside of that character model called Mochi attached, and this character model does not belong to our performer, then we are going to fire server this remote event with the task check for attachment, and then with the current position of our Mochi arm, with the character model, which could be a potential enemy, and with the performer itself. We should take a look at what happens next. So right here, the server script, which has this check for attachment task right here. So what happens is that, let me get rid of this print first of all, is that we have implemented another check, which now checks for, and now you guys know why we have a bunch of variables right here. So val3 is, now I have to take a look at it. So val3 is, I think it is our Mochi arm. Is that correct? Nah, probably not. Nah, it is. Yeah. It is obviously the character model. So the potential enemies, humanoid root part's position minus our Mochi arm's position. So the exact same check as right here. All right, just with different references right here, as you can see. And we have to recheck on the server to really verify that this check has been passed legitimately, all right? Because exploiters can possibly spoof this. And therefore we have to check or recheck on a server if everything is all right. Okay, so that nothing is spoofed whatsoever. And we also have to check for, now I misclick every time. We also have to check for this one, okay, because exploiters can spoof this as well. Now, where is it? Yeah, so that's a check right here. So if both of these checks are valid on the server, then we want to proceed. So what happens then is that we create an int value inside of our enemy, aka character model, whatsoever, call it however you want to call it. And the name of this one is called Mochi Attached. So you guys have already seen it. So this Mochi Attached thing is the instance I was talking about, and we are checking for right here. And this instance marks an enemy as attached to this Mochi arm to prevent it from reattaching. So that's literally the only task it fulfills. That's the reason why we also check for it. And we check that it does not exist inside of that character model, to not attach that character model for a second time, okay? Now, once this instance is created, we fire all clients, so to this remote event once again, with the task attach with val 3 and val 4. Now, let's take a look at this one before proceeding with the rest right here. So attach. Now, as you can see, the val 3 and val 4 are these guys right here. So the target and the real performer. Why did I even call this real performer? I don't know. I cannot remember, but the performer and the target, alright? Now, if real performer not character, find first chat Mochi arm. So that's the first check we have to do right here. So does this Mochi arm even exist inside of that performer? So is he even doing this attack? And if that is the case, then we move on with this code right here. What happens right here is that, wait, this is actually interesting because we have to, I forgot to do this. Come on. I'm sorry, wait, if. Now, we could even do it like this, look. We don't even have to do it like this. We do it like this. So coroutine, resume, coroutine, create function. Wait 12 seconds, v messless faults. There we go, that's the easiest thing we could do. Now, what happens right here is that we loop through... Wait, the real performers. But why? Why the real performer? Why not the target? Wait. Yeah, so we loop through our real performance character by using get descendant, so we literally get anything inside of that character, and we check if v is a part, so the thing we're currently at is a part or a mesh part, and if that is the case, then we check if it is not messless, and if it is not messless, then we want to make it messless. And we have this coroutine right here once again, which waits 12 seconds, and after that we set it back to not messless, alright? But I don't really get why we're doing this on the performer, not on the target. And do not get confused by this. Wait. Val 3? Alright, makes sense. Okay. Val 4. Okay. Yeah, so we have to trust this. Yeah, probably to prevent our perform from glitching. So that's the only thing I could possibly come up with. Yeah, our perform probably glitched while having some people attached on the Mochi arm. That's the reason why we have set it to massless. So that's the only thing I can possibly think of. Sorry. Now right here, hit sound. So we have this hit sound inside of this local script. Hit sound clone. So we clone this hit sound. We parent it to, so we put it inside of our target simulate report, and then we play this hit sound. And once again, we have this coroutine right here, which waits 3 seconds and then destroys the sound. Right here, we have set up another loader. All right, this time we load an animation called hit, which is inside of here. We play this animation. And this one is, of course, the hit animation, as you can probably tell by the name. what happens right here, so this one is interesting, is that we create a Weld, all right? And this Weld now, welds our target, aka our target humanoid's root part, to our Mochi arm's handle, aka the core part of our Mochi, or the Mochi arm itself. I'm sorry, the Mochi arm itself. So this is the point where our enemies stick to the Mochi arm, and that is done via this Weld right here. So pretty interesting. Let me take a look at the C-frame. Yeah, so this is some calculation going on right here. So the x-axis. No, wait. Nah, this is no x-axis. Wait. Yeah, so we take the distance from our target and our Mochi arm, and we multiply this with a completely new C-frame. Yeah, that's how this thing works. Right here we have another coroutine, and after 12 seconds this loader, so this hit animation, is stopped. Now let's get back to, where is it? Right here, alright? So we have another coroutine right here and another loop, and we wait 1 second, okay? And this coroutine, as far as I can remember, is supposed to you know, represent the swinging. So your Mochi arm encircles you at the end, you know, so you rotate with your arm by 360 degrees, and once you reach one round, so one encirclement, we want some certain things to happen, okay? And we assume that after 1 second you have encircled yourself 1 time. Now, every 1 second means by every encirclement we make the swing sound play. Wait, maybe we should remove this then. Up here, so we make the swing sound play, then we create another coroutine which messes with the camera. Like, this is interesting. I think that we should make this performer only, because this is camera manipulation. So I forgot to implement this, I'm sorry. Yeah, so if our local player is the performer itself, then I'm going to do some camera manipulation. And this one is just an effect which emphasizes the swinging, so which makes your camera pulsate. Is that even a verb? I don't know. But cam field of view is being set to 65. We have a tween which makes this pulse. Where is it? This pulse instance, this blur effect, you know, increase in size very fast, and then once it is completed, it is going to decrease it fast. And the field of view, the field of view is being reverted back to 70. I'm sorry. Yeah, that's how this works. And while this happens, we clone an instance from the replicated storage called Shockwave, and we put it inside of the workspace, and we set the C-frame of this one to our humanoid root part C-frame, but we move it a little bit down, I think. So this always confuses me when it comes to C-framing. So when you put a minus in front of it, the instance moves up. When you put no minus in front of it, means the number is positive, it moves down. Very funny thing. And right here we have a tween for this Shockwave right here to turn invisible, but also to increase in size by yeah, 150%. And yeah, so this happens in 1 second, and after this tween is done, we destroy the Shockwave. Now, this whole thing right here happens, alright, as you can see, after 10 seconds of this thing being swung around and checking for people to attach. After 10 seconds, swinging is set to false, which will lead to this loop and to this loop to discontinue. Then the loader is stopped, so this animation which swings your Mochi arm is stopped, and then we play another new animation, so player anim2, which is you or the performer hitting the Mochi arm to the ground. We play this one, and we have a tween right here which moves the Mochi arm while playing this animation. So this tween is required, otherwise the Mochi arm, so you guys have to know that those player anims are only animating the player, and the Mochi arm does not belong to the player, so to the character itself, although it is inside of the character, alright? So we have to animate the character singly and the Mochi arm itself singly. And since I was not able to make the animations on the Mochi arm play, I had to move it via C-frame, you know, and that's the reason why it also looks so shitty. Sorry for that. And what happens right here is that we move the arm up, I think. So we, you know, we play around with the Weld C-frame, and I think that we move the arm up. Once again, we have this check, which checks whether the local script, whether the local player is also the performer. And if that is the case, then we set the camera subject back to to our performer's humanoid. So we revert the camera subject. So we revert the changes, which we have done up here. When it comes to this camera thing right here, then we add another, and then we add a chority, I'm sorry. And this chority makes the camera shake. So we have a loop of 20 loops, and in each loop, our camera offset, so of our performer, is just set randomly, okay? And the lower this number is, so this 50 is, the more intense the camera shake is going to be. And after this loop is over, or those 20 loops are over, we revert the camera offset back to 0, 0, 0. Alright, so once this tween right here is done, alright, so this tween is responsible to move our arm up, our Mochi arm up. Once this is done, we have another tween, which makes our Mochi arm move to the ground, so that you have this ground slam of our Mochi arm. And when this happens, or while this happens, we require a module script, so this GPO Shockwave module script, and we do this create function, and we assign this position. This position is in front of us, so it is the position where our Mochi arm is going to hit the ground. So if you guys want to know more about this GPO Shockwave thing, then check out the video I made on it, alright? So I've made a whole tutorial on it. Don't forget to check it out. And after 1 second, we are going to clone an instance from the replicated storage called crack. So this is going to be a crack shockwave, crack effect. We are cloning it, we are putting it inside of the workspace, and we are moving it in front of us. So just to the same spot as the shockwave going to appear. Now we play a tween, which makes this one disappear, so transparency 1 within 2 seconds. And while this happens, we also play an explosion sound. So we clone it first of all, we put it inside of this crack effect, and we play it. And after 3 seconds, we destroy it. And then we add another wait, which makes this second animation. So this player anim 2, loader stop. Then we have another tween, which makes our Mochi arm turn to invisible within 0.5 seconds. And after that, we just, you know, revert. So we have this check, as you can see, so it's check from up here, but this time we just say that the transparency is now 0. And once this tween, which makes the Mochi arm disappear, completed, we destroy the Mochi arm, we revert our walk speed, our jump height back, and we set our humanoid root parts anchored property to false. And that's it, guys, alright? So that's it with the whole script. I hope that this video was helpful. Yeah, with that being said, link to the model is in the Discord server, guys. Do not forget to join the Discord server and to get the model from there. With that being said, see ya.